Theoretical physics has spent decades searching the standard model for the graviton, an independent spin-2 particle assumed to carry gravitational wave energy across the universe. To resolve modern physics, we must discard the concept of a pre-existing spacetime background. The universe operates strictly as an oscillating field of electromagnetic currents. The first stable datum of this framework is specific. The fundamental propagating field of the universe is strictly electromagnetic, denoted mathematically as F mu nu. This directly opposes the orthodox framework of general relativity. Since Albert Einstein formalized his field equations, the prevailing assumption has been that geometry dictates gravity as a wholly separate physical domain from electromagnetism. Under electromagnetic primacy, geometry, represented by the metric tensor g mu nu, is a trace signature of electromagnetic dynamics. Treating metric geometry as an independent propagating entity introduces insurmountable mathematical contradictions. We can prove this failure by examining the system's phase space. To demonstrate the mathematical elimination of an independent geometric sector, we start with a canonical action of the universe. This equation shows the admissible fundamental action. Notice the explicit absence of the Einstein-Hilbert kinetic term. The metric parameter enters strictly as a Lagrange multiplier, enforcing a constraint against the electromagnetic source. Consequently, the Lagrangian contains no quadratic time derivative. The canonical momentum, pi ij, vanishes identically to zero. The structural consequence of the canonical momentum equaling zero is immediate. On the gauge-reduced phase space, the transverse traceless sector algebraically collapses. Without a transverse traceless sector, no independent Cauchy data can be specified for any geometric degrees of freedom. In the linearized Einstein equations, homogeneous solutions, equations set to zero without an electromagnetic source, violate this phase space admissibility. They require a complete absence of electromagnetic stress energy, which breaks our stable datum. This creates a strict shift in causality. Geometry does not propagate independently. It responds entirely to electromagnetic stress energy constraints. If homogeneous solutions are mathematically inadmissible, free-traveling gravitational waves as independent geometric entities cannot physically exist. Without an independent geometry, we must explain how physical structure achieves stability and localization. Structural persistence occurs through recursive phase closure. The field turns back upon itself, creating a bounded, self-sustaining loop. We measure this stability address using the coherence metric, T. The numerator is formative flow, motive coupling, and velocity. The denominator is containing constraint, magnetic tension, and oscillatory rate. At a perfect impedance match, T equals 1, crystallizing the field into a stable node. Matter is the strictly localized, stable eigenfrequency of these perfectly impedance-matched electromagnetic fields. We observe physical structure at multiple scales, from atomic bonds to planetary masses. To understand how microscopic coherence scales up into macroscopic forms, we track the boundary constraints. This is the recursive scaling law, proving coherence doesn't accumulate additively. The containing boundary of one scale natively becomes the formative substrate for the next. Iterating this compounds into a strict 9-cell architecture known as the 3x3 torsional lattice. The lattice splits into conjugate projections, a Maxwellian operator lattice that maps the formative dynamics, and a polyhedral lattice that maps the containing geometry. Spatial geometry is not a pre-given container imposed on a field from the outside. What physicists observe and measure as spatial geometry is the polyhedral trace signature of nested electromagnetic phase closures. This creates a direct observational challenge. We are looking at the massive concrete vacuum pipe of the LIGO facility. If independent gravitons do not exist, what physical phenomenon did this machine detect? At this press conference, scientists claimed the discovery of space-time ripples. We can explain their exact instrument readings without requiring a spin-2 particle. We start with the Gordon optical metric. This established equation bridges light propagation with an effective metric, showing how a medium's electromagnetic structure dictates wave transit. We apply a structural inversion. The metric perturbation is rewritten as an anisotropic impedance perturbation of the vacuum substrate. This impedance equation is governed by the D'Alembertian wave operator, denoted by the box symbol. This specific mathematical operator guarantees that any substrate torsion perturbation must propagate exactly at the speed of light. The equation governing the substrate response already exists in the standard impedance language. We require no new fundamental forces to explain the propagation of the signal. What conventional astrophysics labels a binary black hole is structurally a binary system of extreme electromagnetic stress energy concentration. Here, we clearly see two localized orbiting concentrations of this intense stress energy, spiraling inward toward each other as their orbit decays. We connect this orbital system to the substrate using a dynamic source coupling law, the electromagnetic stress energy quadrupole moment. As the orbit decays, bound energy converts directly into constraint-determined impedance perturbations, radiating outward. We track this transition using a retarded Green's function response. By combining the quadrupole power formula with Kepler's relation for central forces, we extract the precise mathematical evolution of the signal frequency. Solving the orbital decay rate yields this result, the exact observed chirp scaling measured by the observatories, derived entirely without invoking spin-2 geometry. The inverse distance falloff, the retardation phase, and both transverse polarization modes emerge mathematically from this purely electromagnetic sourced derivation. The theoretical torsion density profile calculated by this equation maps perfectly back to the exact differential phase shift measured by the LIGO detector lasers. LIGO detected the constraint-determined impedance response of the electromagnetic substrate. The model globally closes without the spin